Hello and welcome to another part of the series exploring Portworx PX Motion's features in the new 2.0 release. In this part, we'll be debugging issues in production. So we'll be taking data from production and moving into a test cluster using the PX Motion migrations. And this will all be about the dev test workflow and a proper copy data management tools in your Kubernetes environments. So first we'll use the source cluster here and use kubectl to get the pods currently running in the source cluster. So here you can see there's WordPress and MySQL backing that WordPress. And next we'll take a look at the persistent volume claims. So there's one for the MySQL database and one for WordPress. Both storage classes using Portworx. So Portworx is provisioning those volumes. If we look at the pxctl Portworx CLI, we can also see those same volumes with the same names in Portworx itself, along with a few snapshots that we took automatically for production. And next, we're going to just forward the port for WordPress so we can take a look at the application, the WordPress application running in production. And we're forwarding it to port 8080 on localhost. And if we refresh here, we can see the demo and a few blog posts. If we double click here on a few of them, we can see they're all working properly and we can access the data within them as expected. Now, to simulate a bug, something in the background here will happen and we can refresh our page eventually and there's an issue now, right? So here we can see that the dates have been reset. There's some text that doesn't make sense. The blogs are sort of working, but the data is all gone. So this is simulating a bug kind of found in production. Users hit your website and it's not performing as expected. And we can kind of think about the data being part of the issue, right? So we want to migrate the data in the application to a test cluster and then restore. So here we're taking a look at the cluster pair. And this cluster pair has a storage status and a scheduler status connected to the test cluster. And then we can use storkctl to create a migration. And we give it a name, debug migration. We use the cluster pair. We tell you which namespace you want to migrate and to start the applications and things like that. Now, if we watch the migration as it's happening, it goes through a few different stages: volumes, then applications, then final. So this will happen over time, depending on how big your volumes are. And if we take a look at the destination cluster, we can see the volumes are already there, but they're detached. So it's migrating them, and we can see it just finished and moved on to the application, and now it's done. It says final successful. So if we take a double check on these volumes, they should become attached, and now they're attached. Which tells us the application should be using them. So if we switch over to kubectl to use our destination cluster and take a look at our application, it's up and running in the destination cluster, our test cluster. So if we refresh our web page by using the port on that cluster, we should see the same issue, right? We migrated all the data. We expect the same data, the same issue. So we do. Now we can focus back on the production cluster and restore production. Now, if we look at the clone spec here, we can see that we can simply take a clone of an existing snapshot that we may have had from MySQL when production was live. So we'll go in here and look at one of our snapshots that we've taken quite some time ago that we know production was working well on. We can edit this clone spec so that it's using the snapshot in which we want to restore production to. So we reference that snapshot and then we create it using kubectl. So create that spec file, and that'll go ahead and tell Portworx and Stork to create a volume clone off of that snapshot. And if we use kubectl to check how the PVCs are doing, we can actually see that that clone is referencing is pending right now. If we double check again, it should be bound to that clone, and now it is. And we can see it's Stork snapshot. So now we have a clone that we can reference in our deployment. So if we go into the deployment and edit it, and we replace the PVC with the clone, now the MySQL database should restart. And in theory, right, we have replaced our production database to a well-known snapshot, and our production database should kind of have the correct data. Therefore, our blog should be back up and running. So now we can see the MySQL database is up and running. We'll port forward 8080 again from the production cluster, and now we should go back and see everything is fine again, right? So there's our 2 posts, and it has the correct data as expected instead of the buggy data. So now that production is back to normal, we can turn our attention back to the test cluster and focus on figuring out what's going on with our data. And this is made available because we migrated the application and the database over to our test cluster, restore production, and now we can debug knowing happily production is good. And if we can get a terminal session inside our MySQL container or pod here, we can use the WordPress database and just kind of see what's going on with the different rows in the WordPress posts table. This might give us some insight into some of the issue or what's going on. So if we scroll up to the posts here, we can see the text here, and everything's zeroed out. It's been nulled. Something's going on, and whether that's a person or a process that touched this database, we need to figure that out. We can look at logs, we can do all sorts of stuff, all knowing that production's been restored and we've migrated over the same exact database. We can see the bug. You can see here we are refreshing the test cluster version of the website, and we can go back to the source cluster and do the same thing and go back and refresh, and production is fine. So now we have 2 environments. We've migrated the problem over to the test cluster, and that is enabling the prod test, dev test workflow for Portworx and Kubernetes using PX Motion.